Okay, we're going to continue chapter 6. We're going to do trigonometric functions of any angle, right? You noticed in section 2, right, chapter 6.2, we didn't really have a lot of angle measurements there, right, if any, right? But this lesson, we're actually going to do trigonometric functions of angle measurements. Okay, to start off with, this is stuff that you guys already know, right? You guys already know SOHCAHTOA, relating to right triangles, right? We label the side opposite of our angle theta, the opposite side, the side next to it, the adjacent, and then the side across the right angle, the hypotenuse, right? And you guys already know that sine is opposite over hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent. And you guys also learned in the previous lesson cosecant, secant, and cotangent. They're just the reciprocal of these, right? So you just take whatever you got for sine, cosine, and tangent and flip them. Okay, and we're going to do this in a triangle, but this isn't really going to be the bulk of our lesson. This is just to kind of refresh the idea of how to find a trig value given a triangle. All right, so our goal here is to find the 6 trig values, right, of this particular triangle. Right now, I have 2 sides, and I want to find the third, right? I need 3 of them. Right now, what we have is an opposite side, right? So the side opposite of this angle theta is the 12. We have the adjacent, which is right next to this angle theta, and we don't know the hypotenuse right now. So what we can do is Pythagorean theorem, right? So we're going to use a squared plus b squared equals c squared. All right, in the previous lesson, you guys knew this as x squared plus y squared equals r squared. But now we're just going back to basics, right? You guys know this as a, b, and c. All right, so then this is going to be 5 squared plus 12 squared. Whoa, hang on. Plus 12 squared equals c squared. And that's going to get us 25 plus 144 is c squared. And so we get 169 as c squared. Hopefully we know that this is a perfect square. And so we get that c is 13, right? So the hypotenuse has a measurement of 13 units, all right? And we want to find the 6 trig values. So I'm going to find sine, cosine, and tangent. All right. And then we're going to do cosecant, secant, and cotangent. All right. Now, sine is opposite over hypotenuse. Our opposite side is 12, and our hypotenuse is 13. So it's very simply just 12 over 13. All right. Cosecant, you just take the reciprocal of that, so you flip it. This is going to be 13 over 12. All right. Cosine is adjacent over hypotenuse. In this case, the adjacent side is 5. The hypotenuse is 13, so you're going to do 5 over 13. And then when you flip it, you get secant, right? So this is going to get us 13 over 5. All right. And then tangent is going to be opposite over the adjacent, so we're going to have 12 over 5. And then to find the value for cotangent, you're just going to flip it, so we're going to get 5 over 12. All right, simple as that. All right, hopefully that's familiar, at least some of it with the sine, cosine, and tangent. I know the cosecant, secant, and cotangent are new, but after the previous lesson, right, this actually shouldn't be too bad. All right, more right triangles that you learned in geometry are these special right triangles, right? This is really going to be the super important stuff of this lesson. All right. You guys remember these hopefully as just any arbitrary side measurement A in a 45, 45, 90, right? I'll do that one first. Since these 2 angle measurements are congruent, that means the sides opposite are congruent, all right? So then this is A, this is also A, all right? And the rule for this is that the side opposite of the right angle, so the hypotenuse, is going to be whatever the side measurement was times the square root of 2. All right. You can verify this using Pythagorean theorem if you want, or like let's just say you plug in a number for a, right? If you plug in 5, right? 5 squared plus 5 squared is going to get you 50, and then when you take the square root of it, you get 5 square root of 2, right? Something like that. All right, let me actually write that out. Not the whole formula, like kind of showing you why it works, but let me just give you any arbitrary 45, 45, 90 triangle, right? If I gave you this side, let's say 5, then you already know automatically that the side across from that other 45 is also going to be 5. And the side across from the hypotenuse is going to be 5 times the square root of 2. All right? That part shouldn't be too bad, right? This is just hopefully a refresher from geometry. All right, so the key takeaway there is that you just have to know the rule, right? So you need to know that this is A, and that this is A times the square root of 2. In this image, we see a 1, and a square root of 2, right? That's just the case where A is 1, all right? Now, if you look at a 30, 60, 90 triangle, all right, so hopefully this is also kind of familiar, right? The side across from the 30 degrees, we call that 1, right? In this particular example, it's 1, but any arbitrary measurement, we can call that A, all right? Now the other leg, right, the longer leg is whatever the shortest leg is times the square root of 3. So this is A times the square root of 3. And then the hypotenuse of a 30, 60, 90 triangle is always double the shortest leg, right? So 2 times A, right? Let me give you an example, right? So if I show you this 30, 60, 90 triangle, right, 30 degrees, 60 degrees, and then the 90-degree angle, then we can say, for example, right, the hypotenuse I'm going to say is 24, all right? Well, we already know that the hypotenuse is equal to 2A, so that would make A, right, if you were to solve this out, that would make A equal to 12, right? 24 divided by 2 is 12. And A goes with the shortest angle, so 30, right? So 12 goes right here. And then all you have to do to find 60 is do the shortest side, the shortest leg, times the square root of 3. So 12 square root of 3. All right? Again, that's just a refresher on special right triangles. What we're going to do now is find the 6 trig values of each special right triangle. All right? What I would do from here onwards, all right, is to draw your special right triangles. All right, so let me draw a special right triangle right here. All right, there's my right angle. The angle measurement that you see on this page is a 30-degree angle. That's telling you that we're going to be looking at the 30, 60, 90 triangle, right? So I'm going to say that this is 30 degrees, 60 degrees, and the side opposite of the 30 degrees is A. The side across from the 60 degrees is A square root of 3, and the hypotenuse is 2A, right? So this is the bare minimum that you should know, right? So you should know these side measurements relating to this angle. Since we're trying to find the 6 trig values of 30, 30 is our angle of interest right here, right? So that means the side opposite of 30 is A, right? A represents our opposite side. Now, the adjacent side is the side right next to it, which is A square root of 3, right? This is our adjacent. The hypotenuse, right, whether it's the 30 or the 60, is going to be 2A. So what we're going to do is, now that I have these sides labeled, it doesn't matter if it's A, it doesn't matter if it's any other number. All right, what we're going to do is we're going to use SOHCAHTOA to try to figure out these 6 trig values. All right, let's start with sine. Sine, we know, is opposite over hypotenuse, right? So if you, again, at any point, if you forget that, just make a note of SOHCAHTOA, right? Hopefully that's something, probably one of the biggest things that most of you remember from geometry, right? SOHCAHTOA, right? So we know that sine is opposite over hypotenuse. Our opposite is A, and our hypotenuse is 2A. So I'm going to make this A over 2A. Now, hopefully we see what simplifies here. A and A, right? So because those cancel out, we're left with 1/2. So that means sine of 30 degrees is 1/2. Very simply now, to find cosecant, all we have to do is flip it. All right, this is now going to become 2 over 1, which is just 2. All right, we can do the same thing with cosine, right? So katoa, I know that cosine is the adjacent over the hypotenuse. The adjacent is a square root of 3 over the hypotenuse is 2a. Again, what cancels here is always going to be the a's, right? So then you're left with square root of 3 over 2. So that means cosine of 30 is the square root of 3 over 2. All right, secant of 30 then, I'm going to take the reciprocal. This is going to be 2 over square root of 3. But once again, we don't want to leave a radical in the denominator, so you're going to multiply the top and the bottom by the square root of 3. So that means secant of 30 degrees is 2 square root of 3 over 3. All right, now to find tangent of 30, that's the opposite over the adjacent, right? Again, so katoa, T-O-A, right? Opposite is A over the adjacent is A square root of 3. And then what cancels out here are the A's, right? So this is going to become 1 over square root of 3. And then once again, you can multiply the top and the bottom by the square root of 3, and then this is going to get you the square root of 3 over 3. So that means tangent of 30 degrees is square root of 3 over 3. All right, cotangent, to find this, you're just going to flip it, right? So then to flip what we got for tangent, this is going to be 3 over square root of 3. And then you can rationalize, this is going to give you 3 square root of 3 over 3. Right, lots of 3's, right? You actually can simplify this because I do have a whole number 3 and a whole number 3 on the bottom. They cancel out, and then you're very simply just left with the square root of 3. So that means cotangent of 30 is just the square root of 3. All right, so then those are the 6 trig values of 30, right? You're going to see these particular values are going to show up a lot in this lesson. All right. And as a matter of fact, you're going to see those same exact values on this page, because this time we're looking for the 6 trig values of 60 degrees. Now, once again, anytime you have an angle that's familiar to you, I would draw the associated triangle, right? So we already know that a 30, 60, 90 triangle is going to have these as the following size, right? So this is 30 degrees, 60 degrees. I know that 30 is A. 60 is A square root of 3, and the hypotenuse is 2A. All right, this time our angle of interest is 60 degrees. So that means our opposite is A square root of 3. Our adjacent is A. And our hypotenuse is still 2A. All right, so same exact values as we got in the last page, but they kind of swap, right? The A square root of 3 and the A swapped places, right? In the previous page, it was the A was the opposite, the A square root of 3 was the adjacent. This time it's the opposite, right? So regardless, let's find these 6 trig values, right? Sine is, right, let's use SOHCAHTOA. All right. SOHCAHTOA, sine is opposite over hypotenuse. Our opposite in this case is A square root of 3 over the hypotenuse is 2A. And again, the A's are always going to cancel out, so then you're just left with the square root of 3 over 2. All right. Cosecant of 60, you're just going to take the reciprocal of that. This is 2 over the square root of 3. And then times square root of 3 times square root of 3, we're going to get 2 square root of 3 over 3. All right. If you look on the previous page, we see these exact same values. All right. They just swapped places, right? Before, these were associated with cosine and secant. Now they're associated with sine and cosecant, right? That should probably tell you that the same thing is going to happen with cosine, right? You can probably guess that cosine of 60 is a half and secant of 60 is 2, right? But let's just verify that. All right, so this is going to be adjacent over hypotenuse. The adjacent is A, the hypotenuse is 2A. If you simplify A and 2A, this is going to get you 1/2. All right, and then if you flip 1/2, you get secant, right? So that's 2 over 1, which is just 2. All right. Now let's find tangent and cotangent, right? Tangent is opposite over adjacent. The opposite is going to be A square root of 3. and the adjacent is just a, right? And then when you simplify these, you very simply are left with square root of 3, all right? To flip the square root of 3, right, we don't see a denominator on there. You could write a denominator of 1, or you could very simply just say that this is the adjacent over opposite, right? Cotangent is just the flipped of tangent, so we can say adjacent is a, the opposite is a square root of 3, and then this simplifies to 1 over square root of 3, which we can rationalize. All right, so then this is the square root of 3 over 3. All right, so these are the 6 trig values of 60 degrees. All right, on this page, let's try the exact same thing with 45 degrees. Right, is 45 degrees special to us? Right, it is, right, because this relates to a 45, 45, 90 triangle. All right, so this is 45, this is also 45. I know that the sides opposite of the 45-degree angles are A, and then the hypotenuse is A square root of 2, all right? Because both of these angles are 45 degrees, it doesn't matter which one we use as our theta, right? Let's just say I'm going to use this 45 degrees, all right? Then the opposite is going to be A. The adjacent, the side next to it, is also A, and the hypotenuse is a square root of 2. All right, once again, let's use SOHCAHTOA to figure out the 6 trig values of 45 degrees. All right, sine of 45 is opposite over hypotenuse, so it's a over square root of 2, or a over a square root of 2, and then the a's cancel out, and we get 1 over square root of 2. But again, we want to rationalize this, and this is going to give us the square root of 2 over 2. All right? Now to find cosecant, we're going to flip it. So this is going to be 2 over square root of 2. And then let's rationalize it. This is going to give us 2 square root of 2 over 2. And the whole numbers cancel out. This is just going to get us the square root of 2. All right? Now, if you do cosine, we get adjacent over hypotenuse, which is also going to be a over a square root of 2. The a's cancel out, and so this is going to give us 1 over square root of 2, and then we get square root of 2 over 2 again. All right? Now, if you flip it, I'm sure you can guess, we get the exact same thing as we got for cosecant, right? We get 2 square root of 2, or 2 over square root of 2. And then when you rationalize, we get 2 square root of 2 over 2. And then the 2's cancel out, and we're just left with the square root of 2. All right? So sine and cosine are exactly the same. Cosecant and secant are exactly the same at a 45-degree angle. All right? Let's see what happens at tangent. Tangent is opposite over adjacent, so it's going to be a over a. And anything divided by itself is 1. Right? If you do the same thing with cotangent, we get a over a. Right, adjacent over opposite, which that's also going to get you 1. All right, so then we get these as the 6 trig values of 45 degrees. All right, and then you can see 45 degrees is kind of nice, right, because we get some repeating values that make some of the work a little bit easier. All right, you're not really going to see a whole lot of questions that are strictly asking for 30, 60, and 45 degrees, right? This is really just a whole lot of skills that we use to evaluate at any angle, right? That's the name of this lesson, right? You're going to evaluate at almost every angle, all right? And that brings us to what a reference angle is, all right? So a reference angle, by definition, is just the acute angle between the terminal side of an angle in standard position and the x-axis. All right, so we see 3 quadrants here, right? We see quadrant 2, quadrant 3, and quadrant 4, right? Quadrant 1 isn't pictured, and that's just because if you have an angle in standard position, it's going to look something like this. It's already going to be an angle that we can make a nice triangle out of, all right? But if you look at quadrant 2, we can't really make a right triangle just out of theta. Theta itself is this big angle, right? This is an obtuse angle. So we can't really make a right triangle out of an obtuse angle. So what we use instead is a reference angle, which is this angle right here, right? It's the distance between the x-axis and the terminal side, right? The acute angle, right? Not the obtuse one, all right? And if you do this, you make a little right triangle, right? You guys already know how to do this based on the previous lesson. This time we're actually going to have an angle measurement attached to it though, all right? And to find this particular angle is you take 180 and you subtract your angle theta, right? Why does that work? Is because this is a straight line, which as you guys know from geometry, a straight line is 180 degrees. If I have a piece of the 180 degrees, right, to find the other piece, you just subtract, right? That was pretty common in geometry, I think, right, from what I remember, all right? In the third quadrant, all right, it's going to be something similar, right? So you can see we can't really make a right triangle out of this really big angle right here. So what we do is we use this distance and make a right triangle out of this little angle right here. And this little angle is going to be the angle theta minus 180 degrees. Why does that work? Again, because think of a straight line. A straight line is this distance. And if you went past it, if you take away a straight line, you get rid of this whole upper half and you're just left with this little bit right here, right? And then if you look at the fourth quadrant, if you have a reference angle, this little acute angle right here, right? You have a pretty big angle that you can't really make a right triangle out of, but this little acute angle right here, you can make a right triangle out of. And this reference angle, this little angle theta, is going to be 360 degrees minus theta. All right, and again, the reason that is just because a full rotation would be a circle. And if you take away this bigger part of the circle, you're left with the other little part of the circle, right? So that's that measurement right there. Reference angles are going to help us to find the exact value of almost any angle, no matter what quadrant it's in. Typically what we do is we find the reference angle and we draw the special right triangle to find the exact value. And then what we do to figure out the associated sign attached to it is we use what we did in the previous lesson with the all students take calculus, right? ASTC, to figure out what quadrant a specific trig value is positive in, right? This will all make sense in the next slide once I actually do some examples. Okay, so the goal here is we just want to find the value that they're asking, right? Now, you're going to do all of these without a calculator, all right? Now, you're probably looking at these numbers like how are we going to do that without a calculator, right? I'll show you, right? This first example really shouldn't be too bad, right? It seems harder than it is, but the first thing you want to do is determine what quadrant the angle is in, right? So what quadrant, all right? And 225 is in the third quadrant, right? This is in quadrant 3. How do you know? Because we know that the quadrants go 0, 90, 180, 270, and 360, all right? And in the third quadrant, those are the angles between 180 and 270, right? You guys learned that in the very first lesson of this chapter, right? So I know that this is in the third quadrant, all right? So let's sketch what this would look like. Now in the third quadrant, I know that it's going to be something like that, all right? It's going to be, this is kind of like the rough sketch of our angle, all right? The second thing that you want to do is find the reference angle. So the reference angle, right? What is it? In this case, the reference angle in the third quadrant is going to be theta minus 180, right? Again, that's something that you have to memorize. In the third quadrant, it's theta minus 180. So it's going to be 225 minus 180, and that's going to get you 45, all right? That means this angle right here, right, is a 45 degree angle. All right. The third thing that you want to do is draw the special right triangle. So draw the right triangle. All right, and to do that, we're going to take this edge right here, I'm sorry, this part of our angle, and we're going to say that this is one type of special right triangle. The ones in this lesson are always going to be a special right triangle. It's either going to be a 30, 60, 90, or it's going to be a 45, 45, 90. And in this case, because there's a 45-degree angle, we know that this for sure is a 45, 45, 90 triangle. All right? And so that would mean the side opposite of 45 degrees would be A, the side next to 45 degrees is A, and the hypotenuse is A square root of 2. All right? So that means to find sine of 225 is we're just going to use SOHCAHTOA, right? So let me do step 4. You're going to use SOHCAHTOA. All right, and SOHCAHTOA gives us that sine of 225 is opposite over hypotenuse, which in this case the opposite is A, the hypotenuse is A square root of 2. All right, and the A's cancel out, so we get 1 over square root of 2, and then rationalize, that means this is going to be square root of 2 over 2. All right, it's not going to end there. The fifth thing that you want to do is use all students take calculus to figure out the sign of sine, right? Let's say. Since we are in the third quadrant, tangent and cotangent are positive. Everything else is negative. Since sine is not one of them, this is going to be a negative square root of 2 over 2, right? And that would be your final answer. All right, I know it seemed like a lot, but the more you do these, the easier they get. All right, so let's try the exact same thing with the next one. Let's do the same process, right? The first thing you're going to do is figure out the quadrant that it's in. So I want to find cosine of 150. All right, what quadrant is this in? This is going to be in the second quadrant. Again, just because it's between 90 and 180, and that represents quadrant 2. So I'm going to sketch an angle. In quadrant 2, it's going to be something like that. It doesn't have to be exact. I just know that it's going to be like that. The next thing we want to do is find the reference angle, right? In the second quadrant, the reference angle is going to be 180 minus theta. Again, that's something you have to memorize. All right. What we can do now, right, plug it in. 180 minus 150 is 30 degrees. All right, so what does that mean? That means this angle right here between the terminal side and the x-axis, this is 30 degrees. All right, so that means when I draw the right triangle, right, that was the next step, right, draw the right triangle. This is a 30, 60, 90 triangle, right? Across the 30 degrees is going to be A, right? Across the 60, this is going to be an A square root of 3, and the hypotenuse is going to be 2A, all right? The next thing that you're going to do is you're going to use SOHCAHTOA to figure out what cosine is going to be, right? So I know that cosine of 150 has to be the adjacent over the hypotenuse. And in this case, the adjacent is A square root of 3, and the hypotenuse is 2A. So I have A square root of 3 over 2A. The A's cancel out. This is going to get us square root of 3 over 2. The very last thing you want to do is use all students take calculus to figure out the sign of cosine in the second quadrant, right? In quadrant 2, right, remember this is all students, S, right? So that means sine and cosecant are going to be positive. Cosine is not one of them, so this is going to be a negative square root of 3 over 2, all right? Bit of a tedious process, but the more you do, the better they get. All right, let's try the same thing with tangent of 300, right? Let's go through the motions. All right, first thing you want to do is figure out the quadrant that it's in, right? This is between 270 and 360, so this is in the fourth quadrant. All right, let's sketch that out. All right, in the fourth quadrant, it's going to look something like this, and I know that it's going to end somewhere right there. Right, I don't know how exact that is, but that's fine, right? That's what we're going to used so far. The next thing we want to do is find the reference angle, right? And in the fourth quadrant, the reference angle is going to be 360 minus theta. Again, something you need to memorize. So we're going to do 360 minus 300, which is 60 degrees. All right, so that means this angle right here is 60 degrees. All right, that is special to us because we know that 60 degrees in a right triangle means that it's a 30, 60, 90 triangle, which means the side across from the 60 degrees is a square root of 3. The other leg has to be a, and the hypotenuse has to be 2a. All right, what you're going to do now is you're going to use SOHCAHTOA to figure out what tangent is going to be. Right, tangent of 300 has to be opposite over hypotenuse. I'm sorry, opposite over adjacent, right? The opposite in this case is a square root of 3, and the adjacent is a. So I have a over a square root of 3. Sorry, other way around. Sorry. Opposite is a square root of 3. And the adjacent is a, right? The a's cancel out, and we're simply left with the square root of 3. The very last thing you want to do is figure out, using all students take calculus, what's the sign of tangent in the fourth quadrant. And in the fourth quadrant, we know that cosine and secants are positive. Tangent's not one of them, so this is a negative angle. All right, so that means tangent of 300 is negative square root of 3. All right, slightly challenging, right? Let's try some more. It actually gets slightly more challenging with this, just because we don't know exactly what quadrant this is in, right? This isn't between 0 and 260 degrees, right? So sometimes what you have to do first, right, maybe make this like a step 0, is make sure that it's between 0 and 360 degrees, right? So make sure that it's between 0 and 360, all right? If an angle is not between 0 and 360, what you can do is you can find a coterminal, right? So because 390 is not between 0 and 360, let's subtract 360 degrees to make it between 0 and 360, right? So what's that going to give us? This is going to give us cosecant of 30 degrees, all right? Hopefully we're okay with that, right? What we did is we just subtracted a full rotation just to make the angle easier to visualize, right? And once you do this, you really don't need to go back to 390, right? We don't really care about that number anymore, because cosecant of 30, since it's coterminal, is going to give us the exact same value, all right? So from here, let's go through our motions, right? The first thing you want to do is figure out the quadrant that it's in. 30 degrees is in the first quadrant. All right, so I'm going to draw an angle in the first quadrant. All right, our reference angle in the first quadrant is just the angle, right? So that means this angle right here is very simply going to be 30 degrees. So that means I can draw a special right triangle. That means the side across the 30 is a, the other leg is a square root of 3, and the hypotenuse is 2a, right? If we don't know what cosecant is in terms of SOHCAHTOA, change it to something that you do know. We know that cosecant goes with sine. So let's try to find sine of 30 degrees. Sine of 30, we know, is going to be the opposite over the hypotenuse. Opposite over hypotenuse. That means cosecant has to be the hypotenuse over the opposite. So let's just plug this in, right? The hypotenuse we know is 2a, and the opposite we know is a. So 2a over a cancels out, and we're just left with 2, all right? So that means cosecant of 30 degrees or cosecant of 390 degrees, right? Remember, they're the exact same value, is 2. The very last thing you want to do is figure out the sign of cosecant, right? And in the first quadrant, everything is positive, right? That's what the A stands for. All are positive, all right? So that means positive 2 is our answer, all right? Let's try the exact same process with the next one, right? Negative 150, right? We don't really know where that is, and it's not between 0 and 360, so let's find a coterminal. So I'm going to add 360 degrees. And then when you do this, we get secant of 210 degrees, all right? And again, like I mentioned in the previous one, secant of negative 150 has to be identical to secant of 210. Next thing you want to do is figure out the quadrant that it's in. It's between 180 and 270, so this is in the third quadrant. I know that it's going to be something like that, all right? So then we have an angle something like this, but the reference angle, right, this is really the angle that we're interested in. In the third quadrant, hopefully you remember, is going to be theta minus 180, all right? So 210 minus 180 has to be 30 degrees. So that means this angle right here is 30 degrees. 30 is significant to us because I know now that this is a 30, 60, 90 triangle. This is a square root of 3, and 2a, all right? Secant goes with cosine, right? We know that with SOHCAHTOA, cosine is adjacent over hypotenuse. That means secant of 210 has to be the hypotenuse over the adjacent, all right? So then plugging this in, I know that the hypotenuse is 2a over the adjacent is a square root of 3. The a's cancel out. We get 2 over the square root of 3, right? Multiply the square root of 3 on the top and the bottom, right? We never want a radical on the bottom. So we get 2 square root of 3 over 3. And then last thing we want to do is use all students take calculus to figure out what sign it is in the third quadrant, right? In the third quadrant, T is for tangent and cotangent that are positive. Secant is not one of them, so that means this is negative, all right? Last one for this lesson is going to be cotangent of negative 225. What we're going to do is we're going to add 360 because this isn't in our 0 to 360 range. And when we do this, this is going to be cotangent of 135. All right? Next thing we want to do is figure out what quadrant this is in. 135 is in the second quadrant, so I know it's something like this. All right? And then the next thing I want to do is figure out the reference angle, right? I don't really care about the big angle. We just want to know this little one right here, right? And to figure it out in the second quadrant, it's going to be 180 minus 135, which is going to get us 45 degrees. All right? 45 degrees is kind of nice because we know that this has to be A, and this is also A, and the hypotenuse is A square root of 2. All right? Cotangent, if you're not sure using SOHCAHTOA what cotangent is, right, keep in mind that tangent is opposite over the adjacent. That means cotangent has to be the adjacent over the opposite, all right? And the adjacent in this case is A, so this is going to be A over the opposite in this case is also A, so I get A over A, which is 1. Last thing you want to do, all students take calculus, right? In the second quadrant, sine and cosecant are positive. Everything else is negative, so this is a negative 1. All right? I know this was kind of a lot for one singular lesson. And then as you can see, right, this last page took the most amount of time, right? But I can guarantee on a test you'll have at least a couple questions like these, and they're all probably going to take the same amount of time, right? There's not really any one that's easier than the other, right? So the best way to get better at these is to practice, practice, practice.